Okay, so now I'm going to go through question number 3. Question number 3. Okay, so this is number pattern. So in this case, for the first part, we're going to find our T6. So there's a pattern that we have given to us. So T1 equals to 0 plus 4 equals to 4. T2 equals to 1 square plus 7 equals to 8. And T3, 2 square plus 10. And T4 is 3 square plus 13 equals to 22. So you can see very clearly there's a pattern for each part. So over here, the second part is plus 3, plus 3, plus 3. I hope you see this pattern. Over here is plus 1, the number before the square. Then plus 1 again. Okay, plus 1 and plus 1. Okay, and the relationship between the pattern number and this is, if this is 1, this is 0. So it's actually n minus 1. So this is 2, this is 1, this is 3, this is 2, this is 4, this is. So when we want to find T6, you can see the pattern. This will be 6 minus 1 squared. Okay, so and therefore, and the number over here is plus 3 and plus 3 again. So we can see plus 6. So it's 13 plus 6. Okay, so the pattern would be T6 equals to 5 square plus 19 equals to, this one of course you can press your calculator. 5 square, 5 square, which is 25 plus 19, that will give us equals to 44. So that will be the pattern for T6. Okay, next part B. We are supposed to find the nth term. Okay, of this itself, Tn. Okay, so this one is slightly more difficult. Okay, so how do we do this question? Okay, first we need to break down into two parts itself. So T1, you can see that is equals to 0 square plus 4, right? So each term there are two parts. So this is first and this second. So as mentioned just now, assuming that this is Tn, the first number over here that we had will be n minus 1 square. Why is it n minus 1 square? You can see that previously highlighted just now, if it's 4 here, it will be a 3. If it's a 6 here, it will be a 6 minus 1. If it's a 3, it will be a 2, which is minus 1. 2 will be a 1, 1 will be a 0. Okay, so therefore if it's an n, it will be an n minus 1. Okay, so that's for this first part. How about the second part? Okay, second part is a bit tricky, so I need to do another set of at the side. So this, you can see the pattern over here. If I were to highlight, probably use green, this number over here, the number over here is, the sequence is 4 followed by a 7 followed by a 10 followed by a 13. So it's a constant plus 3. Correct? So when you have such a pattern, the pattern will be using the formula Tn equals to A plus n minus 1d. Okay, so this A, what does this A stands for? This A is the first term. And of course, this D will be the difference. I don't know if any of you can recall this. Okay, so in this case, the A will be, of course, will be 4. Will be our A. And the difference will be the 3. So all we need to do is we just plug in the value 4 plus n minus 1 times d, which is 3. And if we simplify, it will give us 3n minus 3, and therefore will give us 3n plus 1. Okay, so this is the pattern just for this sequence, which is equal to the second part of this equation. Okay, so therefore, if we're going to come back, so for the second part, we have to put in as 3n plus 1. That will be the second number that we have. Okay, so therefore the answer will be this, and of course we need to simplify. n minus 1 square is n minus 1 times n minus 1 plus 3n plus 1. So when we expand this, that will give us n squared, okay, minus 2n plus 1 plus 3n plus 1, and simplify further, it will give us 3n plus 2. And this is correct? Oh wait, I make a mistake. Let me see. Okay, yes, there's a mistake here, so it shouldn't be plus 3n. Okay, because it's a minus 2 plus 3, that will give us just n. Okay, and therefore we show. Okay, so that is for part B. Okay, so let me just draw a line, and next question. So part C, we are supposed to explain whether 100 is a term in this sequence. So now, of course, Tn is the formula, is the equation, where n squared plus n plus 2. So this is the equation. So usually will be linked. We want to explain whether 100 is a term in this. So basically, we want to say that 100, can we solve this? Is 100 a solution, or whether it's a term? Okay, part of the answer. So all we need to do is check, try to solve this, and if you can solve this, if can. What do you mean by if can solve this? Meaning to say that n is a integer. So n is a pattern 1, pattern 2, pattern 3, that means it's a solution. If it's not an not integer, after solving it, that means this number, this 100 is not a part of the solution, or it's not part of the term. Okay, so what we need to do is over here we try to solve it. So bring the 0 over, maybe let me just erase this, and okay, so bring it over, n squared plus n, bring 100 over, becomes 2 minus 100 give us minus 98. And when we try to solve it, okay, so it will be, if we use the mode 3-3, it will be very easy. Mode 3-3, this is a equals to 1, b equals to 1, c equals to minus 98. Okay, 1 equals negative 98. Okay, and press equal. You can see that the solution for n is 9.41 blah blah blah, or is minus 10.41 blah blah blah. Okay, so you can see that n is a number with decimal place. So does it make sense? So what does the n stands for? If you look at this, the n is the, which pattern is it? Okay, I highlight over here, n is the Tn. So we cannot have an n where there's a integer. N is a which pattern? T1, pattern number 1. T2 is pattern number 2. T3 is pattern number 3. So we cannot have a pattern number 9.41 pattern. So therefore, the conclusion we should have for this question is no. Okay, since n is not an integer value, so 100 cannot be one of the term, cannot be a term in the sequence. Okay, so that's for part C. Okay, so now next, moving on to part D. Okay, so this is much harder. So Tn and Tn plus 1. So sounds very complicated and sounds confusing, right? Okay, so all we need to do is, when Tn, we already know what is Tn. Tn is n squared plus n plus 2. So what is Tn plus 1? So Tn plus 1 is basically your value over here is, just now all these are n. So now all we need is to replace this with n plus 1. Okay, so instead of n becomes n plus 1. Why is that so? Because when it's, okay, sorry, let me just bring it back. Okay, so how do you do that over here? So all we need to do is we will have to expand. Okay, because we want to find what is Tn plus 1 minus away Tn. Okay, so we try to find these two values first. So we already have Tn, so what we need to find is Tn plus 1. So this will be n squared plus 2n plus 1 plus n plus 1 plus 2, and we simplify, that will give us n squared plus 3n plus 4. Okay, so this is the second term, Tn plus 1. Okay, Tn plus 1 equals to this. So let me erase off this. So now we need to do the minus part. So Tn plus 1 minus away Tn. So in short, we're going to just put this here. So n squared plus 3n plus 4 must minus away this term over here, which is must put a bracket, and therefore n squared plus 3n plus 4 minus n squared minus n minus 2, and if we cancel out, and this minus this will give us 2n, this minus this will give us a 2. And if we see this, right, we can see that because they are asking for, is this an even number? So how do we prove it's an even number? To prove it's an even number, we just make sure that we know that it's a 2 times something is always an even number. Okay, of course, the something must be an integer lah. 2 multiplied by a term, integer must always be an even number. So we try to factorize. So it looks like this: 2 times n plus 1. So therefore, when it's 2 times n plus 1, where n is an integer, therefore n plus 1 is an integer. So 2 times an integer must always be an even number lah. Okay, so therefore, so we just explain n is an integer, and therefore n plus 1 is also an integer. Okay, and therefore 2 times n plus 1, since anything 2 multiplied by any integer will give you an even number. Okay, sure. Okay, so that's for part D. So that's all for this question.